So in this video, we are going to review how to add and subtract fractions, specifically with unlike denominators. In this first problem, it says, which of these fractions correctly completes the equation? Here we have 3/4 plus 11/6 equals, and here are my solutions. First thing I do notice is I have a proper fraction and an improper fraction. Doesn't matter if you even have a mixed number, improper fraction, proper fraction, it is the same process for every type of fraction you see. Now, I also happen to notice that the two fractions given to me are different denominators. So the first thing I'm going to do is write out the denominators on the side. I'm going to list out my multiples. 4, 8, 12, 16. Let's list out my multiples of 6. 6, 12. Now I actually stop right there because I notice I have 12 as both multiples. Therefore, 12 is going to be my least common denominator. Now I'm looking at my answer choices, and right away I do see one answer choice with 12. Now 48 could also be a potential option as well, but let's confirm and see if C is correct. Now, even though it says 12 is my denominator, let's just check it out. So I'm going to rewrite 3/4 plus 11/6. Now for this problem, I'm actually rewriting this horizontally. In the next problem, I'll rewrite it vertically. Now here, I notice I want my denominators to be 12. Now notice here, I rewrote that, showing me that each fraction is going to have a denominator of 12, which I determined here by listing out my multiples. Now I'm going to look here and I decide, I'll do this in green, 4 times what number gets me to 12? Think to yourself, what did I do to 4 to change it to the number 12? Well, 4 times 3 is 12, and if I multiply my denominator by 3, I multiply my numerator by 3. So now my new numerator for this fraction is going to be 3 times 3, which is 9. Now 3/4 is equivalent to 9/12. It's very important that you recognize that these fractions are in fact equal. Now I'm looking here and I have 6 times some number got me to 12. Well, 6 times 2 is 12. So if I multiply my denominator by 2, I multiply my numerator by 2. So 11 times 2 is 22. Now my last step, I simply add my numerators. 22 plus 9 is 31, giving me a final answer of 31/12. Now that's confirming that answer choice C is correct. Now, oftentimes when I see these problems, especially if you see large words written, equivalent, equation, evaluate, always read the problem and then look at the numbers given to you. Look at the equation given to you. You might even want to rewrite this on scrap paper, get your answer, and then determine, well, what is my correct answer choice? And compare what's on your piece of scrap paper to what's on the screen to help you determine the answer to the problem. Now in this next problem, it says George bought a box of fruit that weighed 3 1/2 kilograms. If he gave away, taking away 2 5/7 kilograms of fruit to his friends, how many kilograms does he have left? Notice I underlined keywords. I circled important pieces of information. In this problem here, I have 3 1/2. I have 2 5/7. The keywords I underlined, gave away, have left. Those are all keywords for subtraction. Now, right away, I notice, my denominators are not the same. So on the side, I'm going to list out 2 and 7. Let me list out my multiples. 2, 4, 6, 8, 10, 12, 14, 16. Now let's go to 7. 7, 14. Whoa, right away, looking here, I did in fact stop because I see that 14 is listed as multiples for both these numbers. Therefore, 14 is going to become my new least common denominator. Now I'm just going to rewrite my whole numbers here. I'm going to fill in 14, 14, and even in my answer choice is going to be 14 as a denominator. Notice I already have half of this problem done. Now I need to just figure out my equivalent fractions. So if I take a look at 1/2, I see 2 change to 14. Well, 2 times 7 is 14, so if I multiply my denominator by 7, I need to multiply my numerator by 7. So 1 times 7 is 7. Now I'm looking here and I see 2 5/7. Well, 7 times 2 gave me 14 as my denominator. So if I multiply my denominator by 2, I multiply my numerator by 2. So 5 times 2 is 10. Now I'm ready. I created my equivalent fractions. My denominators are the same, and I am able to subtract. But now I'm looking to subtract, and I see 7 minus 10. Uh-oh, I can't do that. So in red, I'm going to show you what we need to do. We do, in fact, need to borrow. Now, we have mixed numbers here. I don't really feel like changing these to improper fractions and then subtracting. Instead, I'm going to actually go through the process of borrowing. So I'm going to borrow 1 whole from 3, changing this 3 to a 2. And that 1 whole I borrowed, I'm going to write on the side. Now I notice whatever this 1 whole is, I need to add it to 7/14. But if I'm adding 1 whole, it's much easier to change 1 whole. So the denominator is also 14. And I know that if I divide anything by itself, it also equals 1 whole. So I can represent 1 whole as 14/14. Now I chose to use 14 as my numerator and denominator because notice that's my denominator in this problem. So I wanted to figure out a way to rewrite the number 1 so it makes it really, really simple when I need to add 1 whole to 7/14. So now I can simply add this 1 whole, or 14/14 to 7/14. So when I add these two fractions together, I now get 21/14. And I can't forget about my whole number here. So now I'm actually going to just rewrite 2 and 10/14 so you can clearly see what I'm subtracting. Notice this fraction here, I rewrote it one more time. So now I have the same denominators. I look at my numerators one more time. Now I have 21 minus 10, which in fact I can do, creating my numerator of 11. And I look at my whole numbers, 2 minus 2 is 0. So that's no whole number. So the final answer to this problem is 11/14 kilograms. So again, when you are adding and subtracting mixed numbers, improper fractions, create those equivalent fractions, changing the denominator so they are in fact the same. When you change a denominator, you change the numerator as well. You do that by multiplying, and you can also divide as well to determine your equivalent fractions. Now, always look before you subtract. Can you subtract, or do you need to borrow? Okay, in this next problem here, we have a table of values. The table below shows the weight of several books. In fact, I see we have 4 books. We have the weight in ounces. I notice these weights are in fact mixed numbers. And I also notice that my denominators are different. What is the combined weight of all the books? Well, combined is another word for total, which is another word for sum and addition. So I need to ultimately add 7 1/3, 7 4/8, 4 3/4, and 6 1/3 all together. But I notice my denominators are different. So I see that I have 3, I have 4, and I have 8. I'll just go like this, draw a line down. Now I didn't write 3 again for this fraction because I already have 3 right here. So now let's list out my multiples. 3, 6, 9, 12, 15, 18, 21, 24, 27. Let's list out my multiples for 4. 4, 8, 12, 16, 20, 24, 28. Well, this is great. I see I have 24 and 24. Now let's list out my multiples of 8. 8, 16, 24. Oh, this is wonderful. Notice I have 24 as a multiple for 3, 4, and 8. Therefore, 24 is going to become my least common denominator. And in fact, my goal is to change each of these fractions so the denominator is 24. That makes it really simple to add these together. Now, to change these fractions, what I am doing is I'm creating equivalent fractions. So what I'm going to do is I'm actually going to rewrite 7 1/3, but I know I want 24 to be my denominator. I'm going to write 7 4/8. I have 7, and I'm going to just write 24 as my new denominator. I have 4. I'm going to write 24 as my new denominator. 6, and I have 24 as my new denominator. Now notice I did something to both these fractions, all of these fractions. In fact, I changed the denominator to 24. Now I went from 3 to 24. I went from 8 to 24, 4 to 24, 3 to 24. For each of these fractions, I multiplied the denominator by some number. Now, if I multiply the denominator by some number, I need to also multiply my numerator. So in blue for this problem, let's take a look at 7 1/3. Let's see, how did I change that? 3 changed to 24. Well, 3 times 8 happens to be 24. So if I multiply my denominator by 8, I multiply my numerator by 8. So 1 times 8 is 8. Now I look at 7 4/8. 8 changed to 24. Well, 8 times 3, we learned from the previous problem, is 24. So 4 times 3 is 12. Notice this created my new numerator. Now I have 4 3/4. Well, let's find an equivalent fraction. 4 times some number is 24. Well, 4 times 6 is 24. So 3 times 6 is 18. Notice I changed one part of the fraction, I changed the other part. Here I learned from the other problem as well. 3 times 8 is 24. So 1 times 8 is 8. Now I look at my problem and I see this is great. It's so great because all my denominators are the same. And I have new numerators, but really what I ultimately have is 4 new fractions that are all equivalent to the original fractions given to me in this table of values. So now to find my final answer, I need to add my numerators together. So I see here I have 18, I have 12, I have 8, and I have 8. So now 8 plus 2 is 10, 10 plus 8 is 18, and 18 plus 8 is 26. 2 plus 1 is in fact 4. So now here I have 46, and I have the same denominator of 24. And now let's just add my whole numbers together. 7 plus 7 is 14. 14 plus 4 is 18. And 18 plus 6 is 24. So now I'm looking at my answer. I have 24 46 24ths. That's a little crazy here. Notice we have a whole number and an improper fraction. In the previous problem when we were borrowing, that's okay to convert a fraction to look like this. But when we're describing the weight of several books to somebody, and I told them that the books weighed 24 and 46 24ths ounces, they'd probably look at you and really unsure on what you just said. So let's convert this and change this to a mixed number, a real mixed number where we have a whole number and a proper fraction. So in red, let's go over how to do this. 46 24ths. Well, let's break this into two pieces. So I have 24 24ths. That's one whole. So if I use 24 24ths, I still have another piece of 24ths left. Let's see, 46 minus 24, we're left with 22. So notice I broke 46 24ths into two pieces, 24 24ths and 22nd 24ths. We know that 24 24ths is equivalent or equal to one whole, but we still have 22 24ths. So now this looks like a mixed number. Notice I converted this improper fraction to a mixed number. So now my final step here is I can simply add these two together, giving me 25 22nd 24ths. Now, again, 22nd 24ths, that's a big numerator and denominator. When that's really large, you can create an equivalent fraction by either multiplying or dividing both your numerator and denominator both by something. This process of dividing is called simplifying. So I notice they're both even numbers. So if I divide my numerator and denominator both by 2, that's creating a new fraction of 25 11 12ths. So now here, I'm just going to write this over here because I'm running out of space. We have our new answer of a combined weight of 25 and 11 12ths ounces. That's how much all the books weighed. Now, you're not required to simplify things, but when we're talking about real life situations, it's much easier to explain something if you do simplify your answer. It's not mandatory, but now describing this to somebody, it's much easier to interpret. Now I also see 25 and 11 twelfths is really close to 1. So we might also just round this or approximate this to 26 ounces.